Hi everyone, this is Dr.K.Prathapchandran, Assistant Professor from the Department of Computer Applications, Negru Arts and Science College, Coimbatore. In this sessions, I'm going to talk about Internet of Things. So, before going to discuss in detail, just we know some basic things about Internet of Things. So what do you mean by Internet of Things? Actually, this term is known by everyone, right? It's simply, right now we are called it as IoT, right? It's a trending technology because it is mingled with our day-to-day life, right? And it is not a single technology, rather than it is a combination of multiple technologies like RFID, radio frequency identification, cloud computing, sensors, and wireless sensor networks. So combining all these technology together, it became an Internet of Things, right? So the applications are ranging from personal usage to industrial usage. I could say that a mobile phone is the best example of Internet of enabled devices, right? So what do you mean by, before going to discuss, we should know the basic term Internet and things, right? Because combination of these two elements are it formed, it became an Internet of Things, right? So what do you mean by Internet? So Internet, we know that interconnection of different networks, that is called Internet. So what do you mean by things? Simply things are an objects, right? So the objects are basically classified into two things. First one is physical object, another one is virtual object. So the physical objects are nothing bad. The things are such are surrounded with us. For example, I could say that chair, fan, table, whatever it is, anything. It may be a building, car, bike. Simply the things that are surrounded with us. That is called a physical object. So those physical object or things that are embedded with the sensors that are having sensing the outside environment. Okay, so it became a physical things, right? So virtual things. So virtual things are nothing but a software. So software is nothing but it is capable of being stored, processed, and accessed. For example, I could say that any multimedia content or any kind of application software. So that is called a virtual things. So this is the best example. For example, this is the physical object. I could say that I said earlier. So an object may be anything. So these objects are, embedded with any sensors. Okay. So after that, each objects have a unique IP address that are associated with the internet, right? So it become a smart object, right? So this is the example of physical things. And next thing is logical things. Logical thing, as I said earlier, it might be a mobile application software. It's simply a kind of images, slide source, videos, audios, etc. So what is the definition of Internet of Things? Actually, there are many definitions are pointed out by many researchers, right? So the best example is the sensor and actuators embedded in physical objects are linked through a wide or wireless networks, often using the same IP address, that is internet protocols that is connected to the internet, right? So simply I could say that a piece of device, a monetary capability of communications and optional capability of sensing, actuation and data capture, data storage and data processing. So this is the exact definition of Internet of Things. So anytime, any place, anything. Okay, like our ATM machine. So ATM machine, we can say that automatic telling machines. So simply it is called as an ATM. Similarly, so IoT, we could say that it is an any time, any place, anything. That is, it enables anytime communication. Okay, there is no time restriction. That is, we can communicate at any time, right? During night or daytime or whatever it is, we can communicate. We can able to communicate at any time. So during and any places, okay, so there is no restriction in place also. For example, in outdoor, indoor, okay, so we can communicate like that. And then things communications. The things are nothing but I said earlier, any object, okay. So the communication happened between the computers or human to human or human to things or thing to things, whatever it is. So because there's a reason, so IoT is it is called as a anytime, any place, anything, right? So next we are going to discuss the connectivity among the IoT devices. There are three types of connectivities are there. The first one is P2P, person to person communication. Second thing is M2P, machine to person communications. And third one is machine to machine communication. So these are the three types of communications is available in Internet of Things technology. Next, somewhat fundamental characteristics of IoT. So there are many characteristics are there. Let's start with self-configuration, right? So what do you mean by self-configurations? Okay, so there is no need of human interventions while enabling the Internet IoT, I mean Internet of Things devices. Okay, it is invoked automatically. So that is the features called self-configuration. Then connectivity. So I said earlier there are three types of connectivity in Internet of Things. For example, we have to come back to the previous slides, that is person to person communication, message to person communication, and message to machine communication. So these are the three types of connectivity are there. So third one is heterogeneity. Heterogeneity in the sense, I mean the devices involved in the IoT environment are heterogeneous. That is, they are not equal in their size, speed, memory, and also each and every device has their unique characteristics and unique capacity. That's why it is called as a heterogeneity. And then dynamic environment. So dynamic environment is the sense it is not a static one. So devices are always moving around. So that's why it is called as a dynamic environment. For example, we can consider our mobile phone. Okay, so we can carry the mobile phone wherever we want to go. So it is one of the characteristics. And then unique identification. So unique identification in the sense each and every IoT device have a unique address, right? Unique address like our mobile phone identification number, or our computer or laptop identification number, right? So every device in the IoT environment must have a unique identification number. And then sensing, absolutely sensing, it is one of the main characteristics and component of IoT. Okay, so the sensing characteristics is used to capture or used to observe the outside environment, that is called sensing. And intelligence, so depends on the situations the IoT devices will react. Okay, that is called intelligence. That for that machine learning technologies are inbuilt with IoT devices, right? Then finally large scale in the sense that we can include a number of IoT devices, depends on the applications. Next, we are going to discuss about how the IoT environments are works. Before that, we should know about the layering concept, right? So, in fact, there is no layering concept in IoT, right? So, people would say that there are three or four or five or seven layering concept, right? So, in that case, we are going to discuss about the seven layering concept. Okay, so like our ISO YSA reference model in networks, there are several layers are there. So the layers are this people are sorry, people or process layer, application layer, data analysis layer, data ingestion layer, global infrastructure layer, connectivity or edge computer layer, and things. So these are the three layers are in three layers are there basically in IoT environment. So each layer having their own responsibility. For example, layer one. So layer one, it's simply pointed out the physical things, that is physical devices or sensors, controllers, etc. The main responsibility of this layer is to sense the outside environment, right? So the second layer is communications. Okay, it's mainly concentrated on communications and protocol networks. So once the informations are gathered from the layer one, so the layer two take a responsibility to transfer this whole information to the cloud infrastructure, that is falls in the layer three. Next, after that, in the layer 4, data analytics can be done with the help of data analytics tool like and then big data analytics, miscellaneous algorithms like that. Followed by in layer 5, report can be generated after analyzing those data. Report can be generated or data mining can be done. So those are the things are happening at layer 5. And layer 6 is responsible or simply it's a application side, right? So it is deals with user application side. And finally layer 7, it deals with the decision making. Okay, so that is called that can be happened in the layer 7. So this is five layering concepts. Okay, what we have discussed in the seven layering concepts also same thing in the five layering concepts also, right? So next, the architecture of IoT. So as I said earlier, there are three architecture are there. The first one is sensing, second one is middleware, and then third one is application layer. So middleware layer are classified into two category again. The first one is processing layer and the network layer. Then application layer are again classified into two category. One is business layer and application layer, right? So let's discuss one by one. As I said earlier, sensing layer is responsible for sense the outside environment. Okay. So for that, each devices in the IoT environment having the capability of sensing, or it may be enabled with RFID tags, right? It works based on the concept of real-time operating system, right? So this is the function of sensing layer. Second thing is network communication or middleware layer, as I said earlier. So whatever informations are collected from the sensing layer, it hand over to the cloud, with the cloud that can be taken over by the communication protocols. So communication protocols are nothing but we know that IPv6, it is a common IP protocol, internet protocol that we are using right now. In addition, with some other communication technologies are there like Bluetooth, Zigbee, Wi-Fi, 4G and 5G. So these are the some of the technologies are used to transferring the data from the sensing layer to the upper layer, right? And then finally, interface or services or application layer, right? So these are the layers mainly take care of the application side. So this is the three layering concept, of course. Next, so what are the essential technologies of IoT? There are six technologies are there. As I said in the beginning, it is not a single technology, rather it is a combination of multiple technologies. Like first one is sensor, radio frequency identification. Third one is wireless sensor networks, middleware, cloud computing, and IoT application software. These are the technologies are involved in IoT. Let's discuss one by one. The first one is sensors. So what do you mean by sensors? Sensors are nothing but a device that are used to capture the outside environment, right? In general, there are many sensors are there like accelerometer sensor, proximity sensor, IR sensor, gas sensor, temperature, chemical, smoke, and motion detection sensor. Okay. So these sensors are using depends on the depends on the applications where that are used. For example, I could say that mobile phone. In mobile phone itself, we have many sensors like accelerometer sensor, temperature sensor, color, humidity, proximity, touch, magnetometer. For example, with the help of temperature sensor only, we can able to know the current temperature in our mobile phone. Similarly, color and accelerometer sensor are used to rotate our mobile phone into landscape mode or portrait mode. So these are the responsibility of sensors in IoT. The next, yeah, this is the different types of sensors physically. For example, color sensor, PIR sensor, water flow sensor, and then humidity sensor, touch sensor. These are the sensors are using right now, right? Next, one more technology that is called radio frequency identification. Simply, it is known as RFID. So, from this picture, you could see that what do you mean by RFID exactly, right? So, it simply consists of a tag, or it simply consists of a barcodes, right? So, these barcodes are in the electronic format, that is electronic product code. For example, you often when you go to I mean a departmental store or in some shopping malls, you often see this type of things, right? So the barcode is there. Someone come and scan your product. By the way, the bill can be raised, right? So this is the best example of RFID. Of course, it is one of the main technology that is using in IoT environment. And some more examples are barcodes, license plates, and then student ID, serial number, car keys, database keys. So everywhere RFIDs is using. The next, yeah, there are three types of tags are used. For example, passive RFID tag, active RFID tag, and semi-passive RFID tag. So passive RFID tag that is not battery powered, whereas RFID tags are somewhat battery powered. And then semi-passive RFID is a combination of two, right? So the next thing is wireless sensor networks. So wireless sensor network simply known as WSN. Okay. So from the picture you could hear that these sensors are enabled with various sensors. Okay. These collection of various sensors are formed together in becoming a wireless sensor networks. And middleware technology is nothing but its application independent software that provides service that allow communication between applications. Okay. So the purpose of using middleware in IoT is it's simply used to hide the complexity, right? For example, you could say that like operating system is the best example of middleware applications. The next is cloud computing. So it's cloud computing that is mainly used to provide on-demand services in IoT environment, right? So if we want to store huge amount of data that is being collected from the IoT environment, and those data will be stored in the cloud computing for further process. So cloud computing is also one of the enabling technology in IoT. So now we will discuss how the IoT environments are works. Okay. So there are five tips involved in IoT: data ingestion, data transmission, data processing, data analytics and production, and data visualization, and finally data analysis and prediction. So first step is data ingestion. So data ingestion is responsible for gathering the data from the outside environment, followed by data transmission. The data transmissions, it simply transmits the data to the data processing environment, nothing but a cloud computing environment. In fourth step, after with the help of collected data, the data visualizations can be done, right? So finally, we can make use of some error analysis or predictions. Okay, that will be happening step 5. So this way only IoT environments are working. So this is in a real world example. For example, you could see that this is agricultural field where the sensors are deployed in order to monitor the agricultural land, right? So here the sensing capability, the sensors are used to observe the agriculture land and collecting information from the agriculture land, and those information can be transmitted to the gateway node. Okay, via gateway node it will reach to the internet, and again it will go to the application user application area, that is nothing but application, mobile phones. Okay, so this is a real world example of cloud computing. Next, these are some of the companies are offering IoT products. For example, Amazon, Kodai, and then Plex, Google Cast. These are some of the companies that are offering IoT environment. Next, we are going to discuss some applications of Internet of Things, right? So, as I said in the beginning, IoT applications are ranging from home applications to industrial applications. They are using in everywhere. For example, transport, unlike logistics, industrials, environment, smart cities, smart building, agriculture, consumers, everywhere IoT devices are using, right? Let's start with IoT application, that is smart application, smart home. Okay, so smart home in the sense, for example, if you want to ask some key questions like, would not you love if you would switch on your air conditioner before reaching home? Switch off lights even after you have left home. Unlock the door to front for temporary access even when you are not at home. So the solution for all these questions become an IoT. Okay? So IoT, for example, I could say that Amazon Alexa is just the best example of smart home applications. Similarly, Philips have already introduced the bulbs. Okay, then they are energy enabled bulbs. Okay, so those things are simply IoT enabled devices. Uh, for example, some more applications are there. Suppose if you want to, switch on your air conditioner with the help of your mobile phone, means yes, it is possible. Or else, suppose during the daytime, the lights are automatically switched off. Like that, yes, we can do with the help of IoT environment. So these are some of the best example of IoT environment that having smart home applications, right? So the next, yeah, this is the IoT, technology in IoT usage of IoT technology in various places of our home. So we can make use of IoT in various places like alarm panel, PR detector, smoke, smoke alarm detector, like that, right? Next, wearable devices. Simply wearable devices, nothing but we can wear those IoT devices, right? For example, smartwatch, right? And then smart headphone. Okay, so smart glass. So these are the best example of wearable IoT devices, right? The next one is connected cars. So nowadays, all the cars are to become connected. They are enabled, they are embedded with IoT devices in order to provide smart driving. For example, the companies like Delta, BMW, Apple, they have already started working with connected cars. Then industrial internet. So industrial internet nowadays, industrial IoT, it's also getting popular with the help of IoT. Nowadays, all the industries are enabled with IoT environment, right? From the picture, you would say that how the IoT environment are using right now. Then finally, smart cities, right? Yes, nowadays, governments is always insisting the smart cities by installing the sensor and various applications throughout the city, and to make the city become smart. So the main advantages of making smart city in the sense we can enabling the easy transport access, or we can enable we can able to store the energy like that. So these are some of the things, enabling things that are used in smart cities. Then for agriculture, so agriculture also getting popular with the help of IoT. So nowadays IoT is mingled with the big data analytics in order to in order to increase the productivity in agricultural land, right? So here IoTs are mainly used for soil moisture, nutrition, controlling water plant growth, monitoring temperature, and determining custom fertilizer. So these are the some of the applications are IoT in agriculture land. And then healthcare, yeah, nowadays hospital also make use of IoT environment very well, right? They can we can able to monitor the blood sugar level, and and then pulse level. All these things is possible with the help of IoT environment. And finally, poultry and farming. Yes, poultry and farming. If we want to keep track of our, I mean, our animals, in the sense we can make use of IoT technology. Suppose during sickness of the particular animals, we can able to track them where it is goes, where it is coming from, like that. Okay. So these are the applications of IoT and poultry and farming also. So simply, these are the IoT. This is the simple IoT demonstration of application for IoT. Suppose if your meeting was booked back 45 minutes, if you want to know that, in a sense, yeah, we can do that with the help of IoT. Suppose if you want to know the driving nearby driving, what's that nearing nearby petrol station, in the sense, yes, you can able to identify with the help of IoT. So simply, IoT is used to be everywhere. That's the thing I want to say.